I introduced my robot in my first YouTube video called LotBot the Robot. That video identified LotBot as having 3 computers, a Raspberry Pi and 2 Arduinos. I made a lot of modifications in the course of developing LotBot. I initially used a Wii remote to send commands to LotBot. There's a very good tutorial on the internet that shows how to hook up a Wii remote to a Raspberry Pi. I then started using this RF remote with its USB adapter. Both of these remotes did not have enough buttons to support entering all of the commands I wanted to use. So I went to this mini keyboard with its USB adapter. LotBot was developed with the main computer, the Raspberry Pi, receiving commands from a remote and sending them to 2 different Arduino computers using a USB connection. One to control the robotic arm and the other to control its motors and wheels for movement. Recently, I became interested in understanding what would be involved in having no physical connection between these computers or subsystems, and the implications for larger systems. My first LotBot YouTube video shows you what these USB connections look like in the previous version of LotBot. The Raspberry Pi 3 comes with both Wi-Fi and Bluetooth hardware support. I decided to use the Bluetooth interface as LotBot's Raspberry Pi and Arduinos will always be in a Bluetooth range of each other. The Arduino Uno computer does not come with a built-in Bluetooth. An HC05 or HC06 module can be attached to the Arduino to provide the Bluetooth support. Both would work for my requirements, but the HC05 has 2 extra pins and a little bit more function that I don't need. So I'm going to be using the HC06. One of the issues is that the voltage level on the HC06 data pins is 3.3 volts, and the Arduino is 5 volts for its digital pins. The Arduino's RX receive pin can accept the 3.3 volts from the HC06 TX transmit pin. In binary terms would be a 1 or a high level. The Arduino's TX transmit pin sending a 5 volt to the HC06 RX receive pin will produce a defect in the HC06 as it is expecting in binary terms a 1 to be 3.3 volts. This can be corrected, which I did, by interfacing a 1K and 2K resistor as a voltage divider to reduce the 5 volts to an acceptable HC06 voltage level. I had to wire the voltage dividers for the 2 Arduinos differently, as one needs to be flat underneath the robotic arm. The other one can just stand straight up in the robotic arm. The way I wired them allows the voltage and ground pins of the HC06 to fit directly into the Arduino's 5 volt and ground header. The HC06 interfaces as a serial interface so that my existing Arduino C++ serial code did not have to change. However, this also requires the data pins to the Arduino TX and RX pins be removed when using the USB connector to download Arduino programs from an IDE on a development computer. This is my development environment. I have LotBot on my desk, and behind it I have my Mac that shows the previous video. And off to the side I have a 65-inch display, my television that's hooked up via HDMI to a $35 Raspberry Pi computer. Seems like an overkill, but it gives me a lot of information. When you install the Blueman, in the preference area, the Blueman Manager, is added to the preferences. So if you select that, you can look at the Bluetooth devices there that can be found in the local area, which are the two HC06s that I've installed on my Arduinos. And there are the addresses underneath the names. You'll notice that the two names are exactly alike, so you can't really do too much unless you go in as far as the name goes. You can't go in and search for the name since you won't know which one it is. So you really need to know what the address is, and the address is given to you in the Bluetooth devices. And then you can set them up by pairing them to the Raspberry Pi. Those addresses are used in the Python code. Here you see that the 57, the one that ends in 57, is the robotic arms address, and the movement address ends in the 91. I do have a little code here that I use to give me additional information. You do not need to go looking for additional devices, but I do use the discovered devices to see what else there is, and I print out those devices when I run the program. The key thing that you need the device address for is over here where you need to connect to it. And if you do connect to it, there's the LotBot. I speak out, or I have this speech synthesizer speak out the main computer has connected to the robotic arm computer, and you'll hear that in the demo. And also, if the movement has been found, then you will see or hear the main computer has connected to the movement computer. If you run this, you also get my little debug printouts, which I ran over here. And this shows that both the robotic arm device was connected and the movement device was connected. Okay, you will actually hear the comments from the speech synthesizer in the demos. Well, there's one more thing that I need to mention. Actually, two things. One is you can see the little red light blinking on the HC06. That blinks until it gets connected to the Raspberry Pi. The other thing is that when I disconnected the USB connectors between the Raspberry Pi and the Arduinos, that also disconnected the power. So I needed to add some batteries. Now I already had a backup battery for the movement for the wheels, but I did not have a backup battery for the robotic arm, and I did not have separate power going to both Arduinos because the Raspberry Pi supplied the power. So now I had to add two 9-volt batteries, one for each Arduino, and I had to add a second pack of 4 AA batteries for the robotic arm. Now, the big problem is knowing when those batteries are not going to be useful anymore because they run out of juice. So what I did is I had one on there. It wasn't very obvious in the version 1 of LotBot, but I had to install an additional 3 mini voltmeters so that I could see what the voltage is. And I put these in series with the Arduinos mainly so I could see what the voltage levels are and I could get some feel for how the batteries are doing. I also put a switch on there so I can actually turn these on and not have them on all the time. So what I'm going to do is just turn the switch on for the robotic arm and the switch on for the movement. The lower voltmeter is for the 9-volt batteries of the voltage that's left, and the upper voltmeters is the power pack to handle the batteries or the power. It's the alternate power for the shields that are on the Arduinos. Okay, so the bottom one is the Initially the 9 volts for the Arduinos and the others for the motors. Okay, well that is the only thing left that I needed to tell you before I show you a demo, and that's what I'm going to do now. This is the first of 2 demos I'm going to show you.
LotBot is starting up.
This is the same demo I had in my first video about LotBot. The only difference is in this demo the computers are communicating via Bluetooth instead of the serial USB cables. You will hear that the main computer connects to the 2 Arduino computers.
The main computer has connected to the robotic arm computer. The main computer has connected to the movement computer. LotBot can be used with the following options. Please select one of the following numbered options. 1 demonstration with introduction. 2 demonstration with no introduction. 3 normal with voice. 4 normal with no voice. Select the enter key to list options again.
Selecting 2 will execute the demonstration script.
Robotic movements have been activated. Obstacle ahead. Obstacle ahead. Robotic arm has been activated. Robotic movements have been activated. Obstacle ahead. LotBot is shutting down.
This demo shows the robotic arm in a different location than LotBot's movement base. The demo script is the same one my code used for previous demos. Of course, obstacles that get in the way will change the path of movement. The demo starts the same as the previous one, so I'm going to skip the startup speech. The reason I changed to Bluetooth in the first place was to understand how subsystems of a larger electronic system might be able to interface. Now the second demo.
Robotic movements have been activated. Obstacle ahead. Obstacle ahead. Obstacle ahead. Robotic arm has been activated. Robotic movements have been activated. Obstacle ahead. Obstacle ahead. LotBot is shutting down.
I hope you enjoyed this video as much as I enjoyed learning about robotics and making this video with iMovie. If there are any issues or questions, please leave them in the comments. Also, if you are interested in where my activities take me in the future, please subscribe.